All right, this is a continuation of the 2.1 notes from class, looking at the definition of the slope of a graph at a tangent point and expressing that as a limit. So we remember we discussed that you could draw a secant line through a function, and that would be 2 points, and we could actually find the slope of a line that goes through 2 points of a graph. And we discussed that if we change the distance between the points so that the delta x is getting smaller and smaller, we would eventually approach what's called a tangent line, which is a line that intersects the function in just one place. And we discovered that if we wanted a formula to help us find the slope of the tangent line, since we only have 1 point instead of having 2, that we needed to look at ways to use a limit to express that. So we came up with a way to do that by using the difference quotient. So f of x plus delta x minus f of x all over delta x, which if you look at a picture, that's really just slope. That's all it is. But because delta x would be dividing by 0, we have to express this out, work it out, and then simplify. Once we've simplified, we can let delta x become 0, and then that becomes the, remember, formula for the slope of the tangent line. All right, so we're going to look at this example. This is the second one from the notes. We did the first one in class. So it says find the slope of the graph f of x equals 3x squared plus 1 at x equals 2. The biggest thing you're going to have trouble with on an exam is always knowing what should you be doing based on the directions. So remember we said that when it says find the slope at a point or a value for a point, that's when we're talking about finding the slope of the tangent. So the directions there are telling you what your first step should be. So we know we're going to have to do this limit process. So let's write out what it's going to look like. So m tan, remember that's going to be our formula for our slope of our tangent, is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Now, because sometimes the functions get a little bit more messy, it's better to do your evaluations for your function over on the side as scratch work. That way you don't get lost with the complex fractions when we get into some of the harder functions. So I'm going to take this over here to the side. I'm going to do f of x plus delta x. And we're going to work that out. So remember, this is the parentheses inside here is taking the place of our variable in our function. So we say 3 blank squared plus 1. That's our function with the variable pretty much removed and replaced as a blank. Inside that blank, you're going to put x plus delta x. So since it's being squared, we need to write it twice and FOIL it. So x plus delta x times x plus delta x, and then bring down the plus 1. So we'll FOIL first. So x times x is x squared. X times delta x is an x times delta x. Do not try to make that delta x squared, mainly because delta x is its own creature. It's a different variable. And then plus another x times delta x plus a delta x squared, because delta x times delta x. And then we do have the ending of that parentheses and then a plus 1. Ran out of room right there, but that's the plus 1 we brought down. Okay, then we can combine some like terms in the middle. We have an x delta x and another x delta x. So that would be 2 of those, remember, because when we combine like terms, we add the coefficient out front, plus my delta x squared, and then my plus 1. And then we will distribute this 3 throughout the function. So 3x squared plus 6x times delta x plus 3 delta x squared, and then remember, bring down the plus 1. It does not get the 3. It was not inside the parentheses. And that's going to be that, so we don't need another line. So that's all the like terms have been combined. So that's my x plus delta x. Now we have one more piece that goes on top. We also have to have negative f of x. So I'm going to do that in a different color. Negative f of x is just negative 1 times your function. So your original function. So that just changes the signs to negative 3x squared and negative 1. So when we look at this, we take the red portion and the blue portion and we put them as the top of this big fraction. So this is limit of delta x going to 0 of, and I'm going to use my colors, the red one on top was 3x squared plus 6x times delta x plus 3 delta x squared plus 1. The blue one was negative 3x squared and then minus 1. And the whole thing was over delta x. Okay, so if you've done this correctly, some things on top should cancel, specifically everything that doesn't have a delta x in it. So our 3x squareds and our negative 1 and positive 1, those are all going to cancel out. So my top just becomes 6x times delta x plus 3 delta x squared all over delta x. At this point, so we notice that the delta x's that we have, there's one in every single term on top and there's the one on bottom. The reason we went through this whole grueling process of writing out all of these evaluations was that the hope was, by looking at the slope, since when we plug it in originally, that ends up being 0 over 0, we hope that something simplifies out and we can actually find the delta x approaching 0 without dividing by 0. So if we reduce here, we get just 6x plus 3 delta x, because this only cancels one of those delta x's. But that's enough, because now we're no longer having a delta x in our denominator, which means we're not dividing by 0. So we then let the delta x's become 0. And that just makes that 6x. Now remember, this is the formula for the slope of the tangent at a point. The question specifically asked for x to be a point of x equals 2. So to get the official slope, we plug in 2 for x. And so the slope of the tangent line at the point x equals 2 for the function 3x squared plus 1, the slope of that line would be 12. Okay, so now we're at the actual definition of the derivative. Now we've already been doing this, we just didn't call it by its name. So the function that represents the slope of f of x, that's the mtan function we've been finding. So the function that represents the slope of f of x is called the derivative of f at x. It has its own notation. We use f prime of x. That's not like, it looks like an apostrophe, but it's not. And it's read f prime of x, or you can write it as dy dx, which is read as the derivative of y with respect to x. So this is what this means. So the bottom part is always the one you're taking the respect to. That is important because later on we'll talk about implicit, taking derivatives implicitly. So that's important for that. And then the process of finding the derivatives is called differentiation. So this is just our formal definition. Notice this is the same thing we were just doing, but now we're calling it, remember, that f prime of x. So if you are asked to find a derivative, one way to do that is to find it by taking this limit. Now, of course, I already told you in class that after learning this the long way, we teach you a bunch of shortcut formulas, but you still need to understand that we're still finding the equation of the slope of the tangent at a specific value. But we're doing it for the entire function, essentially. And this only is going to be there if the limit actually exists. So a function is differentiable at x when its derivative exists at x. So we're going to find the derivative of the following functions using the limit definition. So these look very similar to the ones we were just doing. It's just you have to know that now, since they've said find the derivative, we're doing this as f prime of x equals the limit of delta x approaching 0 of f of x plus delta x minus f of x all over delta x. So again, we'll want to do some scratch work. So f of x plus delta x is going to be, it's going to be a little bit more difficult this time because this is going to be blank squared minus 5 times blank, and that's going to be x plus delta x and x plus delta x. Those are going in where those x's used to be. When we square this, you kind of started to see a pattern. It ends up always being x squared plus 2x delta x plus delta x squared. If you need to see the foiling on that, write it out, but it ends up always being this, and there's nothing to distribute in front of that. And then on this one, we do need to distribute the negative 5, so that's negative 5x minus 5 delta x. And then for our blue part, we do negative f of x, and that's just negative 1 times the original function. So that's negative x squared plus 5x. So remember, we come back over here to our actual formula, and we bring everything down, and we write what we know. So on top, we now have x squared plus 2x times delta x plus delta x squared minus 5x minus 5 delta x. We also have a negative x squared and a positive 5x. Sorry for the cramped space. So that was my scratch work over here, and that's my formula. So all over delta x. Things that are canceling out. X squared, negative x squared. Negative 5x, positive 5x. So notice our blue terms pretty much always get eliminated with stuff in the red part. So this is limit of delta x approaching 0 of 2x delta x plus delta x squared minus 5 delta x all over delta x. A delta x will cancel out of each piece. So that's going to be 2x plus delta x minus 5. Now that there's no delta x making us divide by 0 anymore, we just apply the 0 in anytime we see a delta x. Now, that will just make that 2x minus 5. So this right here is the derivative. So f prime of x is 2x minus 5. Remember what that actually means. That is a formula that will allow you to find the slope of the tangent line anywhere along this function that we choose. All we have to do is know what x value we're choosing to find the slope at. And we plug it in, and that becomes our slope. All right, so we have another one over here to try. So this would be f prime of t, because notice, and I don't know why this doesn't have a t there, but that should have been 3t squared plus 8. So then we're going to apply f of t plus delta t, because we're just using t's instead of x's, minus f of t all over delta t. So whatever variable you're using, that's what you use for your respect. So your function is in terms of that letter. So then when we do our scratch work, we get, I'm going to have to come down here to do the scratch work, I think, for this one. So f of t plus delta t would be 3 times t plus delta t squared plus 8. We already know that that's going to be 3 times t squared plus 2 delta t's, 2t delta t plus delta t squared. And all of those t's and pluses blended together. So let me rewrite that part. So the middle is 2t times delta t and then a plus sign. There we go. It'll actually sometimes help if your plus signs are in different colors than your t's. So that's sometimes why we don't like using the letter t, but you should see that you can do this with any variable. And then we have our plus 8 at the end. So we distribute this, and it becomes 3t squared plus 6t times delta t plus 3 delta t squared plus 8. And then in blue, it's just remember the negative signs of the function. So negative f of t would be negative 1 times 3t squared plus 8. So it's negative 3t squared minus 8. So we go back up here and we plug that into our limit. Which I did not write there, so let's write that in. So f prime of t is the limit as delta t approaches 0. Okay, so for the top we had sorry, I'm having to change colors too much. 3t squared plus 6t times delta t plus 3 times delta t squared plus 8, and then our blue was negative 3t squared and negative 8 all over delta t. So the 3t squareds are gone, the 8 and negative 8 are gone. We're left with the limit as delta t approaches 0 of 6t delta t plus 3 delta t squared all over delta t. Cancel out the delta t's, and we have 6t plus 3 delta t. When we let this be 0 for delta t, that goes away, that whole term, so it's just 6t. So my derivative for that function is f prime of t is 6t. Okay, so the ones that I did here were both quadratic. So what I want to look at next is what happens if the function is a little bit more interesting. Okay, so just looking at the 4 questions that we have remaining in this notes, I'm going to write up the 2 that are very much quadratics, which are just like what we just did. So I'm going to write this one up as a PDF and just attach it next to the notes. And I'm also going to write this one up as a PDF and attach it to the notes because they're identical. They're just different numbers for the quadratics. So the one I want to spend the most time on, the last 2 on this video, are these 2 fractional ones because that's where more of the complexities come in with the difference quotient. So let's look at this one right here. So let's focus in on this. This is h of t is 1 over t plus 3. So we're looking at, remember, h prime. Use the correct notation for your function. It's h, not f. So h prime of t. So the derivative of h, evaluated at t, is, remember, the limit as delta t approaches 0 of f, or h, sorry. We like the f. Of h of t plus delta t minus h of t all over delta t. Okay, so we need to do our scratch work, and that's where this is going to get a little bit more complicated because h of t plus delta t by itself, we have this fraction that's going to be involved. So this is going to be 1 over blank plus 3. So this part's not that bad. You just put in t plus delta t plus 3. So you have a fraction that has a trinomial in the bottom. When you do the negative h of t, it's also not too bad. It's when we plug it back in that it gets messy. So this is going to be negative and then 1 over t plus 3. It's just the negative of this function, so we just make it a negative fraction. Where we get to go plug it back into this limit, we're going to find that we have fractions inside of fractions. And that's the hard part with this, is having to simplify that down. So I like to write delta t over 1 in the bottom, so I see a little fraction there as well. But on top, I have 1 over t plus delta t plus 3. And then I have my minus 1 over t plus 3. The problem with this is that you can't just start combining those fractions on top. And you do need to. You need to combine this so that you have 1 fraction on top and 1 fraction on bottom. That's the only way we can change it to multiplying by the reciprocal, which allows us to clear out those fractions. At least the little fractions. So what we have to do is get a common denominator. And a lot of people just want to throw a plus delta t on the second fraction. That's not legal. You can't just make a binomial into a trinomial. So what we have to do is multiply each of them by the other one's denominator. So we're going to multiply this fraction by t plus 3 on top and bottom, and this fraction by t plus delta t plus 3. So we're creating a common denominator of binomial and trinomial. So then my next line down, I have the limit of delta t approaching 0 is now t plus 3 over t plus delta t plus 3 times t plus 3. So we've got that big fraction there. And then we have minus t plus delta t plus 3 over the t plus delta t plus 3 times t plus 3. Now you don't be tempted to cancel any of that out because we're going to combine the fractions now, and then this is all over delta t over 1. When you go to combine your fractions, be very careful because this negative actually applies to everything on top. You're subtracting that whole numerator. So that actually makes that negative t, negative delta t, and negative 3. If you want to think of it as writing it out. So now I have on my next line, we're going to be able to combine these into one fraction. So this is the limit as delta t approaches 0 of t minus t, so that's going to cancel out. 3 and a minus 3 cancel out, so you actually just get negative delta t as the numerator on top. That's after distributing this negative and then combining like terms across the top. and that's over that denominator of t plus 3 and t plus delta t plus 3. And then all of that, remember, is still over delta t over 1. See if we can move this next one down a little bit. Okay, so then once you get to this point, you can change this to multiplying by the reciprocal of the bottom fraction. So we have our top fraction, and yes, its denominator is still the binomial times the trinomial, times the reciprocal of the bottom, which now becomes 1 over delta t. So now the delta t's can cancel out, and we have the limit as delta t approaches 0 of negative 1 over t plus 3 times t plus delta t plus 3. Now notice this was crucial for us to be able to evaluate this limit because this delta t that was in the denominator was making us divide by 0. Now that it's gone, the only delta t is down here, but it doesn't turn that whole parentheses into 0. So we get negative 1 over t plus 3 times t plus 3 because this delta t is going to become 0. It's going to go away. So the final answer for the derivative is negative 1 over t plus 3 squared. So f prime of t, right over here, is negative 1 over t plus 3 squared. So that's the answer for that one. Okay, the last one that I'm going to do on a video for today is h of t equals 4 over t, just to show you a different variation of a fraction. So we're doing h prime of t again equals the limit as delta t approaches 0 of h of t plus delta t minus h of t all over delta t. Remember, we always do our h of t plus delta t in red just to show our work. So that's just 4 over, and this whole bottom just becomes t plus delta t. You just plug that in where there used to be the t. The negative h of t just is negative 4 over t. So then we come back over here and we write it in our fraction. So on top I have 4 over t plus delta t minus 4 over t all over delta t over 1. Same idea here, we're going to get a common denominator. This fraction needs the t, this fraction needs the t plus delta t. So my new top is, we have 4t and then minus 4 times t plus delta t, so we'll work that out in a minute, all over t times t plus delta t, all over delta t over 1. Okay, so then we combine the stuff on the top that we can, so my limit is equal, of delta t approaching 0 is 4t minus 4t minus delta t over t times t plus delta t all over delta t over 1. On top, the 4t and the negative 4t cancel out. So we get that this is the limit as delta t approaches 0 of negative delta t over t times t plus delta t. And I'm going to go ahead and flip this to multiplying by the reciprocal. So times 1 over delta t. And that's going to cancel. And then notice this is going to be a negative 1 over t times t, because remember delta t is going to go to 0 when we plug that in. So you actually just get t squared. So the derivative is h prime of t is negative 1 over t squared. Now there's just one more thing to talk about on this video, and it's right here below this. It's about differentiability and continuity, because remember continuity was that you could draw the entire function without lifting your pencil, so no gaps or holes or asymptotes. So not every function is differentiable. Below are some examples of a situation where a graph is not differentiable at a point. So there's actually a point that causes us trouble. Most smooth curves are going to be differentiable. So if you have a nice polynomial, you're going to be able to take the derivative all the way through. But there are some places where we get into trouble. We cannot take a derivative at a vertical tangent line. Notice that this right here would have to be vertically tangent to that. We cannot take a derivative if there's a gap, there's a discontinuity. So there's a place where they don't match. We also cannot take a derivative at a cusp. A cusp is a nice curved kind of, you go in at a curve, but you have a sharp point there. And we also cannot take a derivative at a node, which is another sharp point, but you're going with straight lines there instead of curves. So you can't, if it's a vertical tangent or if there's a discontinuity or a cusp or a node, we cannot take the derivative at that specific point. We can take the derivative of the rest of the way of the function, but not there. And that's the end of the 2.1.